I am obsessed with the Japanese Space Agency. So many of their missions just strike me as really cool, both in the kinds of targets that they're attempting to explore, the atmosphere of Venus, bringing a sample return from the surface of an asteroid, testing a solar sail in space, and sending a giant pressurized rover to the moon, bringing home a sample of one of Mars's moons. These are all really cool ideas. And the missions that they put together are very ambitious. Now, sometimes too ambitious, but in general, they are able to accomplish their goals and deliver some incredible science at realistic budgets and have really interesting collaborations with other countries to provide smaller rovers, hoppers, things like that. And so I've been wanting to just understand the history and the series of events that got us to this place where we see the Japanese Space Agency as it exists today. And so how fortunate was I that Dr. Wijeyeratne reached out, had just recently written a book about the history of the Japanese Space Agency, and wanted to know if I wanted an interview. And I said, yes, please. And so that is this. Now, this is a history conversation. We spend most of our time talking about the history of the Japanese Space Agency from before World War II through the war, and then how they created their own homegrown rocket engines and systems and all of the avionics and aerodynamics and flight materials and all of that leading up to the development of the Japanese Space Agency in 2003, their interaction with the International Space Station, sending astronauts to the International Space Station and the space shuttle, as well as sort of future plans, what's happening with the mission to Mars, with the development by Toyota of a pressurized rover for the surface of the moon. So it's a very wide-ranging conversation, very historical, if that's the kind of thing that you're interested in, about a space agency that we just don't have a lot of information about. So enjoy this conversation with Wijeyeratne. Subo, before we get into your book and sort of the history of the Japanese Space Agency, which is what this whole conversation is going to be about, we need your bona fides. How much time have you spent in and around Japan doing sort of, your life's work preparing for this?
So I've lived in Japan on and off for sort of 20 years. I first went there in the early 2000s, about 2004, right after I graduated from university. And I was there for a couple of years on the JET program. And then I went back to England and floated around. And then I sort of went back to as part of my master's. And then I went back again for my part of my PhD. So I've been living in Japan on and off since my early 20s. And I'm sort of in my mid 40s now.
Right. Yeah. And how did you sort of interact with the space exploration efforts going on in Japan?
So my general thing is that I'm sort of a space nerd, a sci-fi nerd anyway, right? So I'm always interested in space wherever I go. And a couple of things I've noticed is, first of all, it's amazing the number of people and the places they are in terms of like where space research is happening. Right? Like you find people in the most obscure places. Like if you thought that the story of the Japanese space program is crazy, I strongly encourage people to look at the Chinese space program during the Cultural Revolution, right? The things happening there are just, beyond comprehension to a lot of us in sort of the 21st century now, right? In terms of the chaos. So I think it's really interesting that people are doing this all over the place. So that's the first thing. Everywhere I go, I find stuff like this. But the second thing is it like immediately struck me that in Japan, particularly because, and I think like a lot of people, growing up, my impression of Japan is of this sort of high technology place, right? We have the Shinkansen coming out of it. We have a lot of consumer electronics. I was a Sega kid growing up. I had a Mega Drive and a Master System. And yet, you would think, therefore, you hear a lot about the Japanese space program, right? You would think that it's one of the things that they're really famous for, but they're not. In fact, a lot of people, I think, don't even know that they have a space program. So my initial interaction with it was, A, I came in thinking, oh, there must be someone doing space stuff here. But B, it's not really terribly famous, and I wonder why, right? And then, one of the things I noticed when I got to Japan was actually within Japan, it's fairly well represented, right? You do have museums and you do have publicity. And in fact, it struck me that the space program there makes a huge effort to reach out to people. And that's why I got really curious about it, right? I was like, how can I explain this dichotomy? On one hand, they really seem keen on informing people in Japan that they're doing this stuff. But then internationally, they're not really pushing themselves as this sort of major space program. And I was kind of curious about that. So that's why I started.
Yeah, I mean, I think we're all so familiar with the history of the U.S. space program from what was going on even before the war to the arrival of von Braun and the various engineers, the early work with the Mercury, the Apollo, Gemini, the into the space shuttle. You know, like we are deeply aware. Many people who are watching this right now watched the first person set foot on the moon. And then that was in comparison, sort of in conflict with the Soviets. And so you became aware of what the Soviets were up to, of course, you know, first person in space, first woman in space. I mean, just like first orbit, like all of these records that they were hitting. And so those are the two space programs that are most firmly embedded in everybody's minds. And then, as you say, Europe has been busy. The UK has a pretty tremendous space program. The Chinese, like, they are launching as many rockets as almost as the US. Like, they're serious. And then the one that we're going to be talking about today is Japan. And I think, you know, we've got a little bit of I think for me, it's always felt like a gap in my journalism that I would love to fill in. And so you reach out to me and said, "Oh, I've written this book about the Japanese Space Agency. I'd like, you know, kind of interview you." Like, yes, please. Can you please come on? And I'd love to chat with you about it. So this idea then of, you know, like, I think let's begin the history lesson and go back to the really the beginning stages of the Japanese Space Agency. When did they sort of get serious about building rockets in Japan?
Yeah, I love the fact that you just said to a history professor, let's get the history lesson started. So here we go, right? I'll straighten my tie.
Yeah.
So, I mean, I think there's really two answers to that question, right? There's the kind of deep history answer, and then there's the immediate one, right? Like, the immediate answer is Japan got serious about making rockets in the late 60s, right? The late 60s, essentially what happened was there was this guy, Itokawa Hideo, who was an aircraft engineer during the war. He'd worked on a variety of weapons of war, flying weapons of war and planes, including one called Hayabusa, right? Which was a fighter jet for Nakajima. So like a lot of very educated, very skilled Japanese engineers after the Second World War, he kind of found himself at a loose end. And there's a couple of reasons for this. One was that Japanese industry generally had been degraded by bombing. Right. I think a lot of folks don't really know about the physical toll the Second World War took on Japan. It's partly because, so for example, at the end of the Second World War, I think it was the city centers of the 20 most populated cities in Japan were completely bombed flat. Right. And what's interesting about that is actually there's a lot of cottage industry in those places. So that means that a lot of the infrastructure and production networks and supply lines are just gone. Right. And so these guys who are essentially functionaries of that system, right, what they do is they imagine new functions and ways we can use these resources and systems. They don't even have the sort of basic infrastructure within which to do their work anymore. So they kind of have to go off and find their own thing to do. And what Itokawa, who kind of casts around for a long time, does he settles on the space program. The other reason that they were in a difficult position, particularly aircraft engineers, was that the United States, during the occupation of Japan, illegalized any kind of aeronautical research. So they couldn't go straight back to aeronautical research. And because, for various reasons, including that the Germans' aeronautical skills were somewhat more sophisticated than Japan's, none of the victorious imperial sort of Western powers were interested in bringing these Japanese engineers anywhere. So they're stuck in Japan. They've got nothing to do. Itokawa originally is convinced that it's going to be the helicopter. He calls it the age of the helicopter. And he comes to America partly to kind of learn about this. But he then actually reads about the biological experimentation being done in preparation for sending animals to space in America at the time. And this kind of gets him going, and he thinks, okay, so now I think it's not helicopters, it's rockets. So he comes back to Japan. He's at a university, Tokyo University. He starts a lab called the AVSA, which is the Avionics and Supersonic Dynamics Laboratory. And that designs rockets. Those are the ones who sort of, they begin working on rockets in Japan. So that's the official story, right? Like, that's the story you'll get in Japan. I think the actual answer, however, goes back sort of 20 or 30 years earlier, right? I think it goes back to the 20s and 30s, because that's when Japanese engineers first learned what rockets were and started messing around with the idea of making rockets in Japan. And so in the 1920s and 30s, you actually have, including people like Itokawa Hideo, learning about rockets, studying them, imagining what rockets would be like if they were made in Japan. So basically making like the cultural space within Japan for rockets, right? And I think the reason that's so important is because you need that space before people will take the technology seriously. There's a great quote, right? Anyone who's played like Civilization 5 will know that there's this amazing quote from Napoleon about someone who came to him about steamships. And said, we can build you a steamship to conquer England. And he says, you want me to sail across the sea on a ship with a bonfire below its decks? Are you out of your mind? Right? Like, so there wasn't that kind of imaginative space for the technology. Right? And I think it's the same for rockets. And so because they make that imaginative space in the 30s and early 40s, during the Second World War, Japan makes a serious effort at making rocket weapons, right? So the first time Japan consistently manufactures and uses rockets is actually during the Second World War, right? So in my heart, that's the real answer. It begins in the Second World War, but the official answer is it begins in the 1960s.
Right. And you touched upon this tension between what Japanese researchers were able to work on compared to what they wanted to work on. And they came up with some pretty creative solutions to be able to continue development in rocketry.
Yeah, so the main thing with Japan was just a quick aside, right, about the context after the war, the political context, and why they weren't allowed to do this stuff, right? Because obviously after the American withdrawal in the early 1950s, 52, technically there was nothing stopping the Japanese from going ahead and just designing ICBMs, right, or just doing whatever they liked. But one thing that they were very keen not to do, obviously, was to annoy the Americans, right? Because the United States was keen, no matter how strong their alliance with Japan was, the fact that they had been at war just 10 years earlier, and that this was a country that could reasonably, within the lifetimes of the people at the time, develop a nuclear weapon, if it wanted to, for it to then have a delivery mechanism to lob those rockets wherever it liked, didn't particularly strike the Americans as something that they wanted to happen. But of course, the other sensitivity is China, right? Which is right next door. It has its own space program. It's communist, and therefore, not only is it historically opposed to Japan because of the things the Japanese had done in China in the Second World War, but it's philosophically opposed to capitalism, which is America, and Japan's imperialism. So the Japanese have to be really careful with the rockets they design, because there's a lot of people they can annoy. The third factor, of course, is that within Japan, people are sick of war, right? The Second World War had a profound effect on people in Japan. Like, people witnessed the destruction firsthand in a way that I think folks certainly North America never did. And so they're very sensitive. They don't want to get involved in nonsense like that again, right? They don't want people bombing them. So there's several things that the earliest space research in Japan did to kind of obviate that, right? The first thing is they foregrounded the argument that this is a national project of redemption. So the idea was this is going to be Japanese made from the bottom up. Everything's going to be made in Japan. And so by basically building out that system, we can show people that there's no part of this system that is dedicated to war, right? So we're going straight to Nissan and asking them to make specifically civilian rocket pieces, right? If Nissan then happens to go use those components in their own missiles, well, that's not really that's not the business of Tokyo University or whoever's doing it, right? We're not trying to make missiles. That's the main thing. The other thing is they limited the kind of rockets they used. So Japan is one of the few countries, if not the only country as far as I know, that's put a satellite in orbit for the first time on sort of a 3-stage solid fuel rocket. And the reason that they really focus in on solid fuel rockets is because obviously, you can't have hyper accurate ICBMs if they're all solid fuel. It's much, much harder to do. Right, you need liquid fuel rockets to kind of get the precision. So that was the initial approach that they took to kind of obviate those dangers.
That's interesting, to, sort of like as a show of good faith, to say we're going to invest in solid rocket boosters because you can't deliver an ICBM with that level of accuracy, and then that gets people off of their back and allows them to continue to develop all the other parts of the rocket, the avionics, the aerodynamics, the payload capacity, the satellites, the tracking, the communications, like all of the bits and pieces that are required for a proper space program, you could still do on a solid rocket platform.
And if I may, I think what you just said is super interesting, right? Because all of that stuff you talked about, all of that can be used like in civilian life, right? You can easily justify the building of all of that stuff by telling people, oh, hey, your telecommunications are going to get better, right? Or you can find your way more easily, or it's good for logistics, right? Of course, and this is the ongoing thing with space technology, right? It's all dual use though, right? So if Japan happened to want to use this stuff for military reasons, and it actually, in the 90s, that's what happened. Japan decides it actually does want to use all this for military stuff. It's almost no effort to integrate it the other way, which is also incidentally why I end the book where I end it, right? Because I end my book with the formation of JAXA. But JAXA is a pretty profoundly different thing to what came before, right? JAXA actually includes military functionality under its umbrella, right? So it's a very different beast. So these strategies I'm talking about, they don't apply after sort of 2003.
Yeah, and and for people who aren't familiar, JAXA was formed in 2003, and then before that it was NASDA
and ISAS and a whole bunch.
Yeah. And so I think one of the big turning points of the Japanese space agency or the space development was the development of their own liquid fueled rockets. And I think most famously was the H-2, which I don't know if they're still operating, but they were operating for a very long time, and they had their difficulties with that rocket.
Yeah, it was a nightmare, actually. In fact, so one of the things I discuss in the book is that I think, so basically what I think happened is that, Japan developed this decentralized space program over the course of the 60s, 70s, and 80s. And the reason they do that is because each space program is doing a different thing. So to go back to that discussion about solid boosters, right? That whole thing about we're only going to do solid fuel rockets, that was an Itokawa Hideo thing. Right. And Itokawa Hideo, his group, AVSA, then becomes a group called ISAS, ISAS, which still exists today. And so ISAS is doing its own thing, and they always kind of focus on solid fuel rockets, or at least in the 60s and 70s they were. And so they were going down their own road. And then what happens is companies in Japan, businesses, particularly telecommunications companies, they very quickly understand that you're never going to be able to use ISAS's rockets to put satellites in orbit on a regular basis, right? They're not accurate enough, they're not powerful enough, they don't have the payload capacity, and they're not necessarily even commercially reliable enough, right? And so they come up against this wall because they're pushing for the introduction of liquid fuel rockets, but the resistance coming back is we have to build this all in Japan, so it's going to take time for us to get liquid fuel rockets up and running. And B, we need to be careful because, obviously they're dual use and they can be ICBM. And in fact, I should also add that concern, right? Like people saying, oh, liquid fuel rockets can be used for ICBMs. That's just not something that the Japanese are plucking out of the air. Like if you look at parliamentary records at the time, like the Socialist Party in Japan, the Communist Party is quite powerful at this time. And they regularly say this, right? They say, look, isn't this just a stealth attempt at developing ICBMs? So this is coming from within Japan as well. So what ends up happening is you've got all these tensions within the system, right? And I think that's one thing I love about telling this story is because when you have stories like you have NASA, we tend to the stories within NASA tend to get subsumed in NASA, right? Like it's a NASA thing, internal NASA thing. Whereas here, because different institutions are fighting each other, it's all out in the open, right? People are being horrid about each other and fighting each other, and you can go find out what they're saying. And so what happens eventually in the 1970s, 60s and 70s in Japan is that this tension builds to the point where the government decides we can't actually change ISAS enough to suit what these companies want. So we're going to found another space program which is entirely dedicated to developing liquid fuel rockets in Japan. And that institution is called NASDA, N-A-S-D-A. And they very quickly become the bigger of the two space programs, right? So ISAS is the big one, and then NASDA is founded, and whoop, very quickly it has all the money poured into it. And very quickly they also discover that making liquid fuel rockets is not as easy as it looks. So the first thing is it takes them forever. In the 70s, it takes them so long. They have the two rocket programs that they're not going anywhere, that they give up, and they finally compromise on one of the main principles they've been going with so far, which is everything has to be made in Japan. They have to import. So they start importing technology from America. But they still want to do it themselves. So even in the 1970s, when Japan is importing American liquid fuel technology, it's quite a fraught process, right? the Japanese want stuff that the Americans aren't willing to give. The Americans are worried that the Japanese are going to compete with them for like commercial rocket launches. So there's a lot of tension. So then in the 80s, they decide to go independent again, right? They decide this time they're going to do it all from scratch, but for liquid fuel rockets. And that's the H2. That's what they're trying to do with the H2. And the reason it's so important, it's going to be Japan's first liquid fuel rocket built from scratch.
And how did that go for them?
Badly.
Yeah.
So, well, I mean, it depends on your point of view, I suppose. Like technologically,
eventually they got there.
Eventually they got there, yeah. But, and there's a lot of like, you know, they learn a lot. And I think that's one of the things, right? Like I think when you're talking about this project, the answer to the question really depends on the perspective you take. Like as an engineering project, it went really badly, right? It went badly for many reasons. It went badly because the Japanese found it very hard to coordinate the provision of resources and precision technologies between all these different agencies. Specialism was, you know, separated out and siloed. But more than anything, the problem was that if they had a problem in one kind of rocket manufacturing, it was really hard to generalize the solution across all the kind of elements of Japan's space program because they weren't coordinated, right? So NASDA would come up with solutions that only really worked in NASDA. ISAS wouldn't be particularly interested in them or apply them because of structural and organizational reasons. So it was a very difficult project overall. And I think that combined with the fact that the H2 rocket, it launched 8 times, it went okay 6 times, but the 2 times it did go wrong were really high profile. Right? There was the first failure, which happened right after people expected it to work. And then the last failure, it lost a really expensive satellite, right? Which caused a whole bunch of ruckus between ministries in Japan. So it was a difficult project in terms of execution, and it was a bad project in terms of perception.
But you know, we reported on the H3 development, which felt very similar. They had one very bad launch, one partially bad launch, and then I think they've had a successful one at this point. But you know, it's the sort of the same story again, which is that building new rocket designs is difficult, even if you have decades of practice at this.
It's hard, you know, and I think the other thing is like every time people make a new rocket, they're always trying to do something new with it. You know, it's not like producing a new family car, right? Like, you know what families kind of want by this point. With rockets, you're always trying to do something new. And I think that, you know, the other thing that kind of undermined the Japanese, I think, a little bit was also stuff that was kind of outside their control, right? So one of the reasons the H2 went wrong was because it became more expensive. But the reason it became more expensive had nothing to do with space technology. It had more to do with the political relationship between America and Japan, right? I mean, this is a time when Japan looked like it might become a superpower. I don't know if you read any Michael Crichton, but like he wrote Rising Sun, which is basically a story about Japanese businessmen are bad, okay? Right? Like don't let them near your women.
Yeah, I remember that time with this sort of like late 80s. You know, I was still in high school at the time, but I remember sort of the rising Japanese supremacy and that it was assumed that their just ongoing momentum was going to carry on forever. And right now we only wanted to buy Japanese cars and Japanese electronics, but eventually it was just going to be everything. And every square inch of Tokyo was going to go for $1 trillion. Like It's just right.
Right.
And then what do you know? It crashed and they've been stagnating for like 35 years now.
Yeah, it's crazy, right? Like, I mean, I vaguely remember that time. And I grew up in like a Japanophilic family, right? So we've always been like Japan, Japan, Japan. So I grew up like hating Japan. I was like, I don't want anything to do with it, which is why I did medieval British history at university. But I eventually got sucked back in. But like, you know, yeah, you're right? Like there was a certain sense of inevitability about it. And also there was a certain element of fear about it, right? People were just sort of like, oh gosh, like what's going to happen next? But, and so partly because of that, the reaction from particularly the United States was to kind of, as the United States saw it, and to a certain extent it is true, to level the playing field between Japan and America. But what this meant was that a lot of Japanese export markets kind of dried up, right? So they had a lot of trouble and then they had the crash. And so it also came at a really bad time for Japan economically. And it turned out that, you know, those circumstances are really bad circumstances to maintain an expensive rocketry project.
Yeah. So we've talked about the sort of rise of the homegrown rocket program. I'd like to talk about sort of their interaction with NASA and the rest of the world in human spaceflight and in some of the collaborative projects that they worked on as well.
Yeah. Yeah, so I think what's really interesting about the Japanese space program is that Japanese administrators have always been very, very good at identifying gaps in advanced research and tailoring what they're able to do to push the boundaries in very specific ways. So the relationship that Japanese space programs often maintain with the American ones is collaboration and the usage of each other's capacity. Japan often relies on America, for example, to launch people into space, even though the Japanese person to ever go to space was this grumpy journalist who went up on a Soyuz, right? And they asked him in an interview once, how does it feel to be in space? And he goes, I want a cigarette, right? Like, so he's kind of a fantastic figure. But, they launch people to the ISS a lot. They participate in the ISS a lot. So one thing that, Japan does is it relies on America to a certain extent for sort of human-rated space travel. They also kind of piggyback off American infrastructure and launchers to, for example, launch their own satellites and own research projects, right? On the flip side, what they do is they'll identify particular areas where the United States, for example, isn't really kind of doing a whole bunch of research, or they feel like that research is not, there's not enough coming out of America and they want it. Right. And so we were talking about Icarus, right? Right before we started speaking, right? And one of the reasons for those people who don't know, Icarus is basically a solar sail experimental satellite. And that's something that the Japanese just kind of felt United States or nobody in the world was really doing the level of research they want to do. And so they do it. And because no one else is doing it, they're the world leaders in it, right? And so they're really good at identifying that kind of stuff. So I think that also goes some way towards explaining things like what are the really high-tech and really cool things the Japanese are doing now? Well, I think one of the coolest things is if Artemis works out, and I hope it does, there's a good chance that they'll be tooling around on the moon in a Toyota. Right?
Yes.
Which I just think is super cool. I used to own a Toyota. I used to own a RAV4. So I feel like a personal relationship. But I also just think that it's kind of a sign of, how will Japan privatize space for their part? Well, they don't necessarily need to produce the next SpaceX. If they produce a company that produces the world's best space buggies, then that's their niche, right? Like they've got a niche. That's how I think they see it.
Like Canada, we build arms.
Yeah, right. Yeah, the Canadarm, right?
Yeah.
And again, the Canadarm is important to the Japanese because they use it for the Kibo external experimental rack, right? So they use the Canadarm to put experiments in there and take them out, if I understand it correctly. So that's exactly the kind of thing the Japanese love doing, right? That kind of collaboration.
Yeah. So I mean, you mentioned one, but there's a list, and I think viewers of my channel know that I've identified something that's sort of very similar to what you're talking about here, which is that there are these gaps that the Japanese not only exploit to actually like try and do some science there, but do it in kind of innovative and what feel like to me very brave ways. We think about the original Hayabusa mission, which suffered all kinds of issues in attempting to retrieve a sample from an asteroid, and like nobody had tried this yet, and it used a range of really innovative technologies on that mission, and it was and in the end it was able to limp back with fractions of a gram of material and deliver it down to the surface of the Earth, followed on by Hayabusa 2, which by all means was a success, both in terms of it bringing back like 5.5 grams of material, but the range of wacky technologies that they deployed as part of that mission. They fired an anti-tank missile at the surface of Ryugu and were able to bring that stuff home. You've got Akatsuki, which was doing images of Venus. You've got Hinode, which is taking pictures of the sun, and more that I'm probably forgetting. And this is leading up to what I consider to be one of the most exciting missions that's in the works right now, which is the upcoming Mars Moon mission. Which is like all of those ideas pulled together, maybe sample return, rovers, hoppers, images, multiple moons. It's going to be bananas.
I think that the way to understand these things, right, is precisely the way you just said. The way it's sold to the public is we got a sample back from an asteroid. That's what we remember, right? But that's not the real accomplishment. The real accomplishment is developing all the technologies that you need for that to happen.
Yeah.
Right? So it's the fact that, so with Ryugu, the fact that they used an anti-tank missile, right, an anti-tank weapon essentially, goes to show that the principle behind it can be deployed in lots of different ways. And this is something I think the Japanese space programs always understood very well. Some of the people who worked on Japanese rockets during the Second World War went on to become mining explosives experts. Because mining requires directed explosions in the same way that rockets are, basically directed explosions, right? So all of that stuff that went into developing Hayabusa 1 and 2 and Akatsuki and MMX, which is the Mars exploration thing, and all of that stuff, that will all then be spun off into the Japanese knowledge economy, right? And into the Japanese manufacturing economy. So that is really like the economic value of those things and why the government invests so much in doing things that way, because they're getting valuable technology back from it. But I should also add, right, kind of one of the things that they want to happen is what we're doing right now. We're talking about it, right? And so that's why those missions are so important to the Japanese now. It's a way of generating pride and of maintaining this notion of cool Japan, right? Because I think one of the things the Japanese state is generally understood is that Japanese culture is a tremendously powerful thing and very popular. And they're hoping that this sort of narrative piggybacks off that.
Right. You get samurai, anime, and Hayabusa.
Yeah,
right?
Exactly. Yeah, that's their hope. Yeah.
Yeah. No, it's worked on me.
Yeah, and I'll be honest, like it's worked on me, and it's not just that, right? Like, I watch a lot of, obviously, I'm a Japanophile, so I watch anime and manga, right? Like, and I think some of the most interesting, and I mean like realistic in the sense that it's grounded on Earth technology and is attempting to be a meaningful exploration of human life in space. I think some of the most interesting stuff comes out of Japan. Like this series called Planetes, Planetes.
Yeah, it's on my list. I haven't seen it yet.
It's amazing.
People keep telling me to watch it.
It's so good because one of the things it points out is, hey, when we go to space, you know what we're going to need a lot of? People picking up rubbish in space, right?
Yeah.
And stuff like that, right? But then at some level, someone in the Japanese government is probably thinking that, right? And they're probably thinking, I wonder if we, like collecting, and then that's how it works.
Yeah. So what are some of the ideas that is being worked on that you're familiar with or aware of in Japan that maybe people aren't familiar with?
So yeah, I think the big one right now is rovers, right? They're kind of working on rovers. But I'll be honest, right? Like rather than any particular technology that the Japanese are working on right now, because so much of it, like you said, is so experimental and so far from being applied on a large scale that I think it's really hard to identify one and say, like, I think this is going to be a major impact. This is going to have a major impact in the future. Like, I think solar sails are really important. But I think solar panels are also really important. I think Japanese solar panels, my understanding is that JAXA's solar panels are somewhere in the region of 3 to 5% more efficient than the solar panels of a lot of other places or a lot of other sources. So there's that too. But I actually think that more important than natural products itself, I think there's a really big change happening in the way Japan manufactures space technology, right? You're seeing a lot far more private enterprise specializing in particular areas. And I'll give you a great example of this, right? There's a company in Japan who are manufacturing, their goal is to manufacture balloons, high altitude balloons that will then be used to take people as close to space as they possibly can, right? So they want to basically get a lock on balloons as a form of sort of global transport, right? A lot of that stuff's happening in Japan, which I think is super interesting. With the space program, I should point out that while JAXA is doing all this science stuff, it's also doing a lot of military stuff now, right? And we don't hear anything about that at all.
Yeah. And another thing as well is that there's sort of a rise of private companies that seem to be spinning off from some of the stuff that JAXA is doing. I think about, say, iSpace.
Yeah.
Companies, there are private lunar landers that haven't been successful yet, but, hopefully soon now. So are we seeing that, like in the US, you've got a pretty vibrant private space space sort of economy. Like people are obviously very familiar with SpaceX. There's also Blue Origin, but there's a lot of then other companies that are part of this as well, both suppliers to those larger companies and companies that are part of, say, NASA's commercial cargo program, the lunar cargo program. You've got Intuitive Machines. You've got, like there's a lot of companies that are sort of have taken some of this technology and then run with it. And what is clearly shifting over to, like, instead of having to be like a purely government driven affair, we're now seeing an actual vibrant private industry that is starting to move this stuff forward. Are we seeing the same kind of thing happen in Japan? So
my sense is that it's not as vibrant there.
Yeah.
Right. And that's partly a function of the relationship between the Japanese state and the corporations that would do stuff like this. So you do have, I think basically if there's going to be companies like that, they have to be startups in Japan, right? And so you do have a bunch of startups, but none of them at the moment are big enough, I don't think, to really be spoken about as major players in any kind of field of technology in Japan. There's a lot of stuff, like I said, the balloon folks are working on these really interesting kind of things on the side. But what they all have in common is that they're all producing either components or particular services and functions, which are intended to service the kind of things that SpaceX produces, right? Or other countries' rockets produce. You don't have a company in Japan that's necessarily a meaningful threat in terms of producing private launch capacity, for example, right? It's all in the technologies. The other reason that that's not happening is that the Japanese government, and I do think this is kind of the case in America as well. Inevitably what happens is the government and the contractors will have this cozy relationship, right? And they tend to kind of get entangled and become a little ossified. I think in Japan, for the longest time, the relationship between big conglomerates called zaibatsu and the government has been effectively the government relying on the zaibatsu to provide certain industrial and commercial and economic services in order to strengthen the country generally. And the government uses these corporations to kind of guide industrial and economic growth in Japan to a certain extent. Now, there are lots of arguments about whether that works or whether that's a meaningful characterization, but certainly that's how people in the 1950s and 60s and 70s in the Japanese government saw it. And I think to a certain extent, they still see that as the government's responsibility, right? Like, we are responsible for protecting Japan, so we're going to have a bunch of contractors who produce stuff for us, but we're going to coordinate defense, right? And we need there to be commercial, kind of a consistent commercial launch, and so we're going to make sure that that happens and contract it out to folks. So what you do end up having is companies like Mitsubishi, right, which produce all of a particular kind of rocket in Japan. And then you have another company that produces all of another kind of rocket in Japan. And you don't have the kind of competition you have in America where you have like Blue Horizon and SpaceX constantly trying to get a drop on each other and pushing each other's boundaries. And I think that kind of ecosystem is the reason for that, right? Not because they're not innovative people in Japan, because clearly there are. And you see that in the work of the startups. It's that the ecosystem doesn't necessarily sustain the kind of thing we're seeing out here in America.
Yeah. Is there a perspective that, I mean, it feels, this is going to get a little political, but, as a Canadian, we are experiencing what it's like to have our economy deeply enmeshed with the United States. Mm-hmm. And we've learned that by doing so, you run into issues if the trade winds change, which they have.
That's very tactful of you, Fraser. Right?
Yes. And so it feels to me like, like we contributed one of the instruments to the James Webb Space Telescope. We put arms on everything that can use them. But we're also working on rovers. We have a pretty vibrant satellite group. We have Bombardier Aerospace. We have all these aerospace companies as well. So I think we are definitely well enmeshed. I mean, there's a Canadian astronaut about to go on Artemis 2. Mm-hmm. So that's exciting. And, we have a long record of Canadian astronauts who've gone to the station. And it sounds like Japan was very concerned about getting too enmeshed with the US, with Europe, with anyone else, and really went with this homegrown strategy. Do you get a sense now that it feels like that's something that they're a lot more proud of? They feel like that was the right direction to go?
I think so. I mean, I guess as a gathering sense, I think that ultimately these things come in waves, right? People, trust builds and then trust fades, and then it takes a time for trust to come back. And I think really what we're seeing here is a collapse of trust between sort of the United States and its trade partners, right, and its allies, right. And I think that's poison for economics, because I think economists and traders, what they crave is stability, right, and predictability. And so I think insofar as that's the case, absolutely. So certainly there is a lot of trepidation on the part of Japan about relying on American supply networks. There is a sense, certainly amongst Japanese conservatives, that we always knew this was coming. America was never really reliable, and we've been warning you about this since, 1800. So there's a bit of that kind of strange schadenfreude I think people get when things go bad. But I think Japan is in a difficult position here. And the first reason is that America is their biggest market, right? So they find it really hard to disengage from the American market because it's not so easy for Japan to transfer its sales to China, right? Nor do they necessarily want to. So they're in a difficult position there. And I think the other reason that they're in a difficult position is because they rely on America for a lot of sophisticated technology, right? There are things that the Japanese need to keep their high-tech industry going that they need to get from America. So they have to be very careful about openly disentangling from the United States, right? Nor do I think it's necessarily in their interest in terms of their scientific missions to disentangle from the United States because, America has some of the best science tech in the world. So here's what I think we will see. I think we will see Japan increasingly investing in independent capacity. But I also think that you'll see that most of that investment is in dual use stuff, right? They're going to explicitly expand in fact, that's what they're doing now. They're building out their dual use capacity. And I think that's where we're going to see changes. And in fact, that's why I think we're seeing changes even right now, right? And I think we've seen changes since the 80s and 90s.
Yeah, I mean, even with the recent missions, there's a lot of collaborations between Europe. Yeah. There was rovers, hoppers, the upcoming the Mars Moon mission is going to have something built by the Germans. So you're seeing this collaboration for the smaller payloads coming from other nations as well. As long as it's on their platform, they're happy to have these partnerships.
And actually, to go back to something you mentioned earlier, but I didn't really talk about, which is the H2, H3 thing. So what actually ends up happening, right, is that the H2 fails, and the Japanese produce a spin-off rocket called the H2A and the H2B. And the difference between the H2 and H2A and B is that the H2A and B have foreign components in them. Right. So what failed was an attempt at creating a 100% local rocket. And so they built the H2A and A and B, and they both work. They're great rockets. They're very reliable and they're fine. And then now the H3 is, again, them trying to make it even more efficient and reduce costs. Right. So what they're doing with those rockets is they're trying to make these cheaper and cheaper rockets, but they're happy to buy components from abroad. That's what that's the conclusion they've come to. Like, we can do this, but we need these components from abroad. So you start talking about like disentangling from America, those components become really expensive suddenly, right? Or hard to get hold of. And so that's why they need to be careful.
Yeah, right. Of course. So is there like a mission that you are looking at above and beyond, we talked about the Mars Moon mission. Is there anything else that is coming in the long horizon? You mentioned, I guess, the Toyota rover, which is going to be like Artemis 6 or something. Is there anything else that people should be starting to get excited about?
I don't know. It's a terrible guest to have on your show, right? Like, you asked me, I don't know.
Yeah, you're a history professor, not a future professor.
I mean, I also write sci-fi, so I kind of am a future person as well, right?
Yeah,
so,
right.
But the reason I don't have an answer directly to your question is because Japanese projects tend to be very small, and so they come together much quicker than you'd expect, right? So a couple of years from now, they might be doing super exciting things. But there's another reason, which is I am actually quite interested in the Toyota rover, the moon rover, right? I'm actually really excited about that because I think it's something genuinely new. Right? Like, so what I find really interesting within space programs and stuff is, like, I think it's easy to get, like, for example, Artemis, right? Like, it's cool and all that. But like, my problem with Artemis is that it's using old technology, which is like super expensive and hard to maintain, and it's cost more than it should, and it's not really particularly new. It's like our take on the Saturn V, and we can do better, right? We can do better. We can do new, exciting things. A commercial car company producing a space rover is something new, right? And it makes me, this is what I'm thinking. I'm thinking that's actually a way of these companies exploring what niches the Japanese can occupy in the coming space economy, right? I think right now, people, when they think of the coming space economy, they're mostly thinking, we need to make rockets and we need to get things into space. And then there's this nonsense about data centers in space, which, why don't you build data centers in Antarctica? It'll be easier, and it's cold out there, right? So don't worry about it.
Yeah, don't get me started on this, but yeah.
Yeah, right? So that's just my humble opinion as me. Mm-hmm. Whereas I think the way serious corporations like Toyota are thinking about this is, okay, so there's going to be niches, right? We need to be able to cater to a particular niche. And what are the niches no one's looking at right now, right? So I wouldn't be surprised if this is actually kind of a test balloon on Toyota's part for seeing, like, to what extent can we make these personal mobility devices in space? right? So I think that's what people like, rather than the missions, if you look at trends like that, it opens up possibility. It gives you a sense of what the coming space economy is going to look like, right? And how these countries are preparing to fit into them in the room that other countries like America leaves behind, right? I think that's super exciting and interesting.
Yeah, yeah. So what are you obsessed with right now?
Oh, okay. So right now I'm obsessed with Tropico 6, which is a computer game, and I'm trying to get it industrialized. But in terms of, okay, my ongoing obsession in space generally is Venus. I'm a huge Venus partisan, and I think everyone's kind of obsessed with Mars right now, and everyone's very excited about Mars, and I think that's great. But there's a couple of things about Venus that I think are really exciting. I think that the Japanese have another Venus project launch plan somewhere in the let me start that sentence again. Somewhere in the Japanese space program somewhere is thinking about going back to Venus. And the rumors are that when Japan goes back to Venus, they're going to use a balloon, right? And this is one reason, because ISAS, this is another thing we didn't talk about, is that the ISAS space program actually controls Japan's high altitude ballooning program as well. And I have an article coming out at some point about that. So it's going to be really cool. This is something that I've always been really excited about, is the prospect of putting a probe in orbit around Venus and then having it slowly sink down on balloon into Venus's atmosphere so we can test it. And there's lots of cool stuff happening on Venus. I think Venus is just really cool.
That's the kind of thrilling, exciting missions that, we can all get behind.
Yeah. So that's what I'm obsessed with. And also the Clockwork rover that they're trying to make for the surface of Venus. I think that is...
Yeah.
So cool.
Yeah, that's a NASA idea. That came out of NASA NIAC grant. I actually interviewed the people behind that idea, and it's really interesting. Some of the really clever ideas for how they can do that, and sort of that done in concert with high temperature computing, which they've been demonstrating at NASA. So you can actually run fairly like rugged fat circuits that are able to do some very simple computing, but you can be running these temperatures that would be able to withstand the heat on the surface of Venus, and would also work well in a jet engine and things like, places where you need high temperature, right?
Right.
And so I think, as the sort of worst place, the most horrific place that you can try to send a spacecraft, it brings out the best in you. The Soviets learned this when they were sending probe after probe into the atmosphere of Venus, and they died, and that's how they figured out how they needed to make it tougher, right? Like, oh, it melted at this altitude. Okay, let's build another one that can handle it even better, until finally they got down to the surface. And so I think that idea is great. And, you mentioned potential balloons. There's been a ton of NIAC NASA NIAC grants that have been awarded to various balloons. There was a recent one that I really liked about essentially generating lifting gas out of the atmosphere of Venus. Use solar power. You can sort of pump gas in, split it, and actually turn this into a lifting gas and sort of stay aloft, and even use this as a propulsion system to move around Venus. Ideas of like manta ray-like body forms that could go up and down in the atmosphere of Venus. So there's a lot of great ideas. And Venus is the best example we have of an exoplanet. And it's right there. Right. And all of the bits and pieces, all the lessons we have to learn to be able to analyze the atmosphere of an exoplanet is there waiting for us to learn at Venus. And the quality of the resolution of the scans, the radar scans done by the Magellan probe on the surface are just, they're just not high enough resolution to pick out the kinds of details that we really want to be able to see. So I 100% agree with you. Venus is the new Europa.
Right. And I think what you just said, right? And it's just, okay, I'm going to probably get it in the neck from all the Mars partisans here. It's just so much more interesting than Mars, right? Mars is cool. Don't get me wrong. I think Mars is cool. I think it's cute, right? But Venus, the surface of Venus, arachnoids, right? Those lava formations that look like huge spider webs, and we have no idea how they form, right? They might just be pancaked volcanoes. Who knows, right? The fact that it snows on Venus, right, up on the mountains, because was it tellurium? The melting temperature at the top of the mountains is just right, where it kind of actually precipitates as a silvery snow out of the air.
Oh, that's crazy. I didn't know that.
Right.
That's
and
amazing.
It lands on the mountaintops of Venus. They have silvery, it's just, why don't we want to go look at this stuff? It's so cool.
Well, I mean, to be fair, there are probably 4 or 5 missions in the works right now to go back to Venus. So, it's other people this has occurred to other people and not just us.
Good. Yeah. Of course.
Yeah. Um, so we should make sure that people know about your book. Do you have a physical copy?
Not with me here. And I'm in my office. I'm so sorry. I should have brought one. I'm sorry.
Yeah, it's the pro move.
It's called The Islands in the Stars. It's called Islands in the Stars, A History of Japan's Space Programs. And it was out last week. It's about 350 pages long. But it basically covers everything I've talked about today from before the Second World War to after. I also have a novel out, if I could plug that. It's called Triangulum. It was a finalist for the Philip K. Dick Award last year, and it's sort of a space opera inspired by ancient Indian myths. So it's precisely as weird as that sounds. Go check it out.
That sounds great. Awesome. Well, thank you again so much. And thanks for doing all of this research and filling a bunch of gaps in my knowledge, both in conversation form and in book form, that I will be able to take my enthusiasm for the Japanese space program and continue on into the future. So thanks a lot.
Thank you for having me. Thank you very much.
I hope you enjoyed this conversation with Dr. Wijeyeratne. I'm going to give you some final thoughts, but first, I'd like to thank our patrons. Thanks to Abe Kingston, Bear Lake Roofing, Brian Bodie, Caradwin, Chuck Hawkins, Commander Baylock, Cy Nielsen, Dark Finger, David Gilton, David Matz, Evan Pro, Greg Feely, James Clark, Jeremy Mattern, Jim Burke, Jordan Young, Josh Schultz, Marcel Smits, Michael Purcell, Nordspace, OneStepForAnimals.org, Paul Buck, Rinkaidu, Richard Williams, Sean Sargent, Stephen Filer Munley, Team 49, Telescopes Canada, Wolfgang Klotz, and Zeldabor Galactic Defender, who support us at the Master of the Universe level. And all our patrons, all your support means the universe to us. So this was great. This was very cathartic for me to be able to have this conversation with Subo. And, you know, based on this, he was able to give me a bunch of other contacts, people I can investigate further at the Japanese Space Agency. And I would love to kind of continue in investigating into the specific missions and programs that I'm fascinated with. But JAXA holds a special place in my heart, that you've got very innovative missions that are trying out new ideas, going to new destinations, attempting with new technologies, things that have never been done before. And it just shows that, we live on this big world and there's a lot of great ideas, and people can find these niches where they can bring service, they can do work that is needed for the future of humanity's exploration, for us to become a true solar system spanning civilization. And these are all pieces of this puzzle. All right, we'll see you next time.